Hi everyone. So, as we all know in computer graphics, 2D transformation functions, the basic transformations functions are translation, rotation, and scaling. With respect to translation, the matrix representation can be written as in this way or in this way. So, the new coordinates will be the old coordinates but with translation parameters. Again, with respect to scaling, which is used to resize the shape of an object, the matrix equation for that is new coordinates will be O coordinates multiplied by the scaling parameters. And with respect to rotation, if it is with respect to clockwise, so new parameters will be old parameters followed by cos theta minus sin theta, sin theta cos theta. If we have this, then we can get easily the anti-clockwise one by anti-clockwise x dash y dash equal to xy, cos of minus theta will be cos theta, sin of minus theta will be minus sin theta, so that becomes plus. Sin of minus theta is minus sin theta, cos of minus theta is cos theta. So this is the case. So here in 2D geometric transformations, so we need something called as homogeneous coordinates, because when we do the operations here, all the operations will be in terms of matrices. So it's not like there should be a generic equation, generic mathematic equation thus fits for all these operations. Example, p dash equal to p into m1 plus m2. Fine, where m1 and m2 are the matrices, p dash is the new coordinates and p is the old coordinates. Let's see, consider a translation. Okay, in translation, we need p dash is p plus t. This is how it looks, correct? P dash is nothing but p plus t. Fine. In that case, here p into 1 plus t means where m1 here is 1 and m2 is t, where t is the translation vector. Now come to the rotation part. Rotation transformation, the generic equation is p dash is equal to p into s, where s is a scaling parameter. So I can return that with respect to generic equation. Here is p into r plus 0 means here m1 will be r and m2 is 0, correct? Something like this, x dash y dash equals xy cos theta sin theta. So I am taking anti-clockwise here, minus sin theta cos theta plus 0 0. Fine. Consider the scaling now. Scaling p dash is p dot s 0 means m1 here is s, m2 is 0 means new x dash y dash will be existing x and y coordinates with scaling parameters plus 0 0. So when we take any geometric transformation, we can make use of this generic mathematical equation in order to perform the operation. Okay, so p dash is p plus t. That's how generally it is being defined. In that case, m1 will be 1 and m2 will be t. For rotation, it is p dash p into r, means where r is the rotation matrix, m1 and m2 will be 0. So this will be your m1 and this will be your m2. The same case with respect to scaling, p dash is p into s plus 0, where m1 will be the scaling matrix, m2 will be 0. So this is m1 and this is m2. Hope I am clear now. My question is, let's assume I have a point here. Okay, with value coordinates x and y. I make a transition. I move it to here to one point and I scale it to enough big size. Then I make a transition so that it falls here. Fine. Again, I'll resize its value so that it becomes small. Something x dash y dash. Usually user will be interested only with respect to the old coordinates value and the x dash and y dash value, not with the intermediate operations. So we can experience a composition of transformations here. Translation, scaling, again translation, scaling. Correct. So in that case, we are interested only in x and y as well as an x dash and y dash. There is something called as homogeneous coordinates that we make use of when we go for composite transformations, because this homogeneous coordinates are nothing but a coordinate system. It treats all the points in the projection plane equally. They convert 2D system into 3D vector, means let's assume this is with respect to 2D transformations. So we'll be taking a 3D vector. When you go for 3D transformations, yes, we'll be taking a 4D vector. Why do they make, they represents 2D to 3D vector as well as 3D to 4D vector? Because this coordinate system treats the points equally in the projection plane. Until unless we get the, we go through the examples, it doesn't make it clear. Consider the general matrix format, that is p dash equals p into m1 plus m2. See, this is very important from exam point of view. So here I'll be removing m2, that is addition part of matrix. Correct. In that case, we get a multiplication matrix form. We get a multiplication matrix form. Example, in order to achieve that, consider this as x, this as y. I'll be taking one more coordinate, that is diagonal to this W. Fine. So this is nothing but a dummy coordinate W. So 2 cross 2 matrix is converted to 3 cross 3 matrix. So yield of that we get with respect to 2 cross 2 or 3 cross 3 doesn't affects the object definitions here. Example, X and Y will be represented with X, Y and W, means 2 cross 2 cross 3 cross 3, 2D vector to 3D vector. Let's assume I'll take this as XW and YW. Fine. I can get this X coordinate from this using this equation when W is equals to 1. See, consider the 2D vector X comma Y and the 3D vector XW, YW and W. So this W is the dummy coordinate now. How will I get this? XW, YW. Take this equation. I can say, claim both my X as well as XW are one and the same now when W equals to 1. So if we retain W equals to 1, this both remains the same. That object doesn't make any effects, means using this homogeneous coordinates, it doesn't make any effects on the object definitions. So we'll take an example. Consider the homogeneous coordinate for translation. Okay, I'll take that as Tx, Ty. So this is with respect to X, Y and W. I'll make the diagonal matrix 1. I'll retain Tx and Ty. The rest I fill it with 0. So how can I write this equation? X, Y into 1, 0, 0, 0, 1, 0, Tx, Ty and 1. Can I just multiply this? X plus Tx, Y plus Ty and 1. So X dash, Y dash. So we are getting in the same form, means new coordinates will be existing coordinate with translation parameter. Y dash is nothing but Y existing Y coordinate with translation parameter. There is no change in the object definition. Correct. But P dash is P into T now. Can you just check the difference here? Previously, with respect to translation, P dash was P plus T. Correct. Means the new coordinate will be existing old plus Tx, the same with respect to Ty. We get the same definition here. Correct. X dash is X plus Tx, Y dash is Y plus Ty. So it's not changing that, it's not making effect on the object definition, but we get a common way of representing the things. Fine. Let's see the homogeneous coordinate for scaling. Fine. For scaling, let the matrix be Sx, Sy. We were filling here with 0 and 0. Now I am taking one more dimension. So this is how it looks. Fine. In that case, what was the equation? P dash is P into S, means new coordinates will be old coordinates. Sorry, it should be 1. Old coordinates and multiply this. Multiply and see. So this is X into Sx, y into sy and 1. This is what you get. So the x dash will be s into xx, y dash will be y into sy. There is no change in the object definition, it remains the same, but we are getting a common generic matrix form, so that can be used. So this helps when we have a series of folds of composition transformations, correct? Translation, rotation, again scaling, rotation. When we have folds of transformations, yes, this homogeneous coordinates helps. So homogeneous coordinates for rotation, for that the matrix is cos theta sin theta 0 minus sin theta cos theta. So the rest will fill like this. So what's the equation? P dash is equal to P into R. So x dash y dash will be xy1 multiply this homogeneous coordinate representation of rotation cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. Multiply this, you get x cos theta, okay, minus y sin theta, x sin theta plus, let me rewrite, x cos theta minus y sin theta, x sin theta plus y cos theta and 1. This is how you get. So your x dash is x cos theta minus y sin theta and y dash is x sin theta plus y cos theta. We can make an observation here. For rotation, there is no change here. So your x dash will be x cos theta minus y sin theta. Yes, it's the same. And y dash is x cos theta plus y cos theta. Y dash is y sin x sin theta plus y cos. It's just the same. But we get a generic, matrix form that can be used when we have a series of folds of transformations. Yes, this helps. So this is how about use of homogeneous coordinate system in 2D composition transformations. Hope you are clear with the topic. Thanks for watching the video.